So, good morning, guys, and welcome back to today's lesson. We've been talking about quadratic equations. So, even today, we're just going to continue a step ahead of whatever that we've been discussing and talking about. So, today, we're going to talk about the maximum and minimum of the quadratic functions. Okay, so that is what we are talking about. So we are saying that the maximum and minimum values of the maximum and the minimum values of a function, which is a quadratic function. So we are saying the maximum and minimum values of a function f of x, which is equal to ax squared plus bx plus c, are the values at the bottom and top of the graph. Or, of the graph. Let me say of the graph or the curve of the curve. So we're talking about these maximum values and the minimum values. So I was saying that the maximum and minimum values of a function f of x, which is equal to ax squared plus bx plus c, are the values at the bottom and top of the curve. Okay, so let us just stick to the curve of the curve. Of that curve. And we are saying that these are called the turning points. So we're talking about the turning points of the curve. Turning points of the curve. So by completing the square of ax squared plus bx plus c, if we complete the square of this, which we already know how to complete the square of this since we already discussed about that. So if we complete the square of this and if we find that if a is greater than 0, if we find that the value a, which is this one, is greater than 0, then we know that the curve is it's now going to be the minimum, which occurs so this occurs when x is equal to negative b over 2a. Then this is now going to be considered to be the minimum. This is why you find that when you draw your graph or your curve, the graph is now going to turn from the bottom. So I'm going to wrap the top part. And from the same function, when we complete the square, we find that, so if a is less than 0, this now means that this is a maximum, and this also occurs when x is equal to negative b over 2a. So having this, we're just basically talking about these turning points. That's what we are talking about. So you'd find that if we have the maximum, then the graph is now turning from the top. So let us look at some of the examples so that whatever that which we are talking about can now make sense to us. So examples. So we'll start with the first one. Why you've been asked to find, okay, let's say, what is the minimum? So if maybe you're asked to find the minimum value of a quadratic equation, which is 3x to the power 2 minus 4x plus 1 minus 4x plus 1. This is what we've been given. And for what exact value of x does this minimum occur? For what exact value of x does it occur? So we've already been told, or we've already been asked to find the minimum value of this quadratic function which we have, which is 3x to the power 2 minus 4x plus 1. Then there's another part where we've been asked to find the exact value of x, where this minimum value now occurs. So since we've already written the question, we'll wrap the top part. Sorry, I'm also going to wrap the title. So solution. So that is the question that we've been asked, which is 3x to the power 2 minus 4x plus 1. That is the quadratic equation which we've been given. And we already talked about the ways or means in which we can find the value of x. And we agreed that x is given by negative b over 2a. So that is the formula that we are supposed to use. And looking at the quadratic equation which we have on the other side, we can now identify what a is, what b is, and what c is. So from here, we can even say our data, this is where we have a being equal to 3, then b is equal to negative 4, and c is equal to 1. Since we have that, now we can substitute. So this negative affects everything. Then b, this side, we've been told that this is negative 4 over 2, which is being multiplied by 3. This is what we have. Then from here, when we multiply this negative and the negative, this is going to give us 4 over 6. So we're also going to wrap part of the question so that we can write the answer properly. And when we reduce this, this is going to give us 2 over 3 by finding a number that can go in both 4 and 6 without leaving a remainder. And when we pick 1 of course is a trivial value, but when we pick 2 goes into 4 2 times, and 2 goes into 6 3 times. This is why we're having the value of x to be 2 over 3. Perfect. Now that we found the value of x, we also need to find the minimum value of this function. So this function that we have we can also, okay, so let me cut this. Okay, so we've been given this, which is f of x being equal to 3x to the power 2 minus 4x plus 1. And from this, we found the value of x to be 2 over 3. So that is what we are going to do. We're now going to substitute this value of 2 over 3 in the equation that we have, so that we can now know the exact minimum value that this quadratic function is going to give us. So when we substitute here, we're now going to have 3 multiplied by 2 over 3 raised to the power 2 minus 4 multiplied by 2 over 3 plus 1. And from this, we are going to get, this will be 3, then we have 4 over 9 minus this, and this will give us 8 over 3 plus 1. Looking at this, 3 and 9, 3 can go into 9 3 times, and 3 into 3, that will give us 1. So from this side, we're now going to have 4 over 3 minus 8 over 3 plus 1. Then these are fractions, then we have a whole number on the other side, and we know how to add and subtract fractions. From there, we're now going to look for a common denominator, a number that all these denominators that we have can go into without leaving a remainder. And when we look at this, we have 3. So 3 into 3 gives us 3. 3 into 3 gives us 1. Then 1 multiplied by 4, this will now be 4 minus 3 into 3, which is also 1, minus 8, then plus 1 into 3, that is 3. Then we have 3 multiplied by 1, which is also giving us, so we'll now look at sketching. The graphs of quadratic functions. So whatever we are doing here is no different from what we've been doing. It's just a step ahead of whatever we've been doing. So we're just adding up to the work. So if we want to sketch the graphs of a quadratic equation, if you've been given a quadratic equation, how do you go about? How are you going to graph it? How do you plot it? How do you sketch it? So we'll look at some of the steps that we can consider for us to sketch this. So we'll look at steps. So what is the first thing that one is supposed to do? So the first thing that one is supposed to do, this is where we're supposed to find the points where the graph cuts the x-axis. So find the points where x cuts the graph, or we have to find the points where the graph cuts the x-axis. So let us change something. So we can say the points where the graph cuts the x-axis. What are these points? Then after you found the points where the graph cuts the x-axis, the second thing that we're supposed to find is the y-intercept. Y-intercept. Then after we have found the y-intercept, the other thing that we are supposed to find is the turning point. So you can say find the turning points. Or better still, on this one, we can also add find. So we can say find the y-intercepts. Okay, so maybe this seems to be a bit theory and the like. So we'll try to use these steps that we are talking about to solve some questions, so that we will really understand how this entire process, or how we can use all these steps. So I'll wrap them for now so that I can write the questions that we can consider. Okay. So we can say examples. So sketch the graphs of the following quadratic functions. Then, so we can start with A. So for A, if you are given f of x, which is equal to, let's say, x to the power 2 minus 4x minus 5. And from the steps, the first step that we looked at is where we find the points where the graph is cutting the x-axis. So that is what we are going to consider as well. So let's look at the solution. So from the solution, we've been given this function, which is x to the power 2 minus 4x minus 5. And we want to find the points where the graph cuts the x-axis. So from here, this is a quadratic function. So what we'll look at is also finding the values of x in this way. This is a quadratic function. We can use completing of the square, we can use the formula method or factorization method. So in this case, let us consider factorization method. Well, we need to know the product and the sum. So from the product, we have this is -5 and we have -4. So we need to look for two numbers that when we multiply them, we're going to get -5. And when we add those two values, we're going to get -4. So from here, we can have -5 and +1. And if we have such, this simply means that we can write this as x squared plus x minus 5x minus 5. And having I've written this, we can now factor out certain things that are common. So from the first part, we have x being common, which will now be x. Then we have x plus 1. Then on the other side, we can also have, what should we have? What do you think? Anyone? Okay, so we can even say -5. Then we have x plus 1. And from what we have, you can now notice that what we have in the brackets is the same. So this simply means that we have x plus 1 and x minus 5. This whole thing being equated to 0, being equal to 0. Even this will be equal to 0. Then from here, the values of x will now be x. So this is the same as x plus 1 equal to 0 and x minus 5 equal to 0, which simply means that x is equal to -1 or +5. Those will be the values of x. And in this case, we're finding the values of x, which simply means that the value of y is 0. So we want to write them in coordinate form because we're going to plot this. So this is -1, 0, and we have on the other side 5. So let me say and 5, 0. Okay, we're good to go. So we have found the first step. Then the second thing, we're going to find the y-intercept. And how do we find this y-intercept? For us to find this point, we considered y to be 0, whatever we're doing, for us to find the value of x, y was 0. But in this case, we're now going to consider the value of x to be 0. So from the function that we have, which is f of x being equal to x to the power 2 minus 4x minus 5. This simply means that now we are going to consider x to be 0. So we can say when x is equal to 0. So this will be f of 0 being equal to 0 to the power 2 minus 4 multiplied by 0 minus 5. And the answer here we're going to have negative 5. So when you write this in the coordinate form, this is now going to be 0, negative 5. That is what we are going to have. Having have done this now, we're now going back to the turning point. And this turning point that we've been talking about, we'll still go back to what we're doing, like the minimum and the maximum values of the quadratic function. So we're now going to find the value of x. So I'll wrap the first part. Since the points are on the other side. So here we can now say turning points. So we want to find the turning point. So by finding this turning point, we'll find the value of x, which is given by negative b over 2a. Okay, so we still have the equation there, so we're still good to go. So from here, we're not going to substitute. We know that the value of a is 1 because the coefficient of x to the power 2 is 1. And the value of b is negative 4. And the value of c is negative 5. So we are going to substitute in what we already have. So we have this negative. So this will be negative 4 over 2 multiplied by 1, like this, which will now give us 4 divided by 2, which is the same as 2. Okay, so we have found that the value of x is what? 2. Having found the value of x to be 2, we're now going to find the value of y when x is what? 2. So when x is equal to 2, meaning that the function will now be f of 2 being equal to, where we have x to the power 2, we'll now say, okay, so this is the equation that we are looking at because that's the quadratic function that we've been given. So this will now be 2 to the power 2 minus 4 multiplied by 2 minus 5. And from this, we are going to have 4 minus 8 minus 5. And this will give us minus 9. And if we have this minus 9, which is the value of y, the coordinate is now going to be 2, negative 9 as our turning point. Okay, so I want to wrap the other side, but before I wrap the other side, I'll write these points down so that it will be easy for us to graph. Okay, or better still, I can wrap the top part. Okay. So we can just write here that so our turning point, which is 2, negative 9, then we have the y-intercept, which is 0, 5, and finally we have those points, the x, let me say x points, then we have negative 1, 0, and 5, 0. So, okay, so now that we've written this, we're not going to put up our graph. So we're going to have a sketch. So this is our x-axis, then this is the y-axis. Then from the points that we have negative 1, 0. Then the other one we have 5, 0. Then the y-intercepts we have 0, 5, which is somewhere here, 0, 5. And we have the turning point, which is 2, negative 9. So let's say this is 2, negative 9. So this is our 2, then this is negative 9. Yeah, so that is what we have. By the way, sorry, this is negative because what we picked from here was negative. So this 2 is negative. That is the reason why it is down. Then from here, we're going to sketch this. So this is supposed to come like this to cut on the, then it goes like that. Okay. So this graph that we have, it's cutting on this point, it's also cutting at this point, then it's also cutting on the y-intercept, and it turns now where we have the turning point. So this graph that we have here, this is the x to the power 2 minus 4x minus 5. And we are done. It's as simple as it looks on the board. So having done this, we'll do a second example just in case you've missed on 1 or 2 points, so that we can still move together before we can now try our skills. So I'm going to wrap the board. Okay, so our second example, already you know we are sketching the graphs. So our second example, which is going to be B. So our B is x to the power 2 plus x minus 20. So this is what we have. We have x to the power 2 plus x minus 20. So the first thing that we're supposed to do is to find the point where the graph or the curve is going to cut the x-axis. And this is the quadratic equation. So we use factorization method. So we have negative 20 and 1 there. So we need to look for 2 values that after multiplying them, we're going to get negative 20. And when we add those 2 values, we're now going to have positive 1. So we can try out 5 and 4. Let's see. Is it giving us? When we have such, does it give us? When we add the 2. So when we have this, when we add the 2, we're going to have a negative 1. So instead, 4 is supposed to be negative. So that after multiplying this and this, we're going to have negative 20. And when we add the 2, we're now going to have positive 1. So from here, we can now have x to the power 2 minus 4x plus 5x minus 20. Okay, so we are good to go. Now that we have this, we can factor out certain things that are common. So remain with x minus 4 on the other side. Then we remain with plus 5. When we factor out 5, we remain with x minus 4. From here, since what we have in the brackets is the same, then this will be x plus 5 and x minus 4. So all these are equal to 0, equal to 0, even this is equal to 0. And from this, we'll have x being equal to negative 5 or positive 4. So what we found are the values of x when y is 0, because this is equated to 0, which simply means that the coordinates will be -5, 0 and 4, 0. Okay, so we are done with the points. Now what we have to find is the y-intercept. So we're going to find the y-intercept. So let's say y-intercept. And for us to find this y-intercept, we consider x to be equal to 0. So if this is f of 0, we're now going to have, this is the function that we are looking at. We will have 0 to the power 2 plus 0 minus 20, giving us -20. So the coordinates for this, we are going to have 0, -20 as our y-intercepts. Okay, we are good to go. Now that we found the y-intercept, what is remaining is for us to find the turning point. Okay. And for us to find this turning point, we're supposed to find the value of x. And x is given by -b over 2a. So looking at the equation that we've been given, we're going to identify what a is, what b is, as well as what c is. So from here, our a is 1 and our b is also 1. So when we substitute in this, we have negative, then we have b, which is 1 over 2 multiplied by 1, which is going to give us -1 over 2. Now that we found this -1 over 2, we're now supposed to substitute it in this function so that we can find f of -1 over 2, which will now be -1 over 2 raised to the power 2 plus -1 over 2, which is the same as us writing minus here, then minus 20. So from here, when we square -1 over 2, this we are going to have 1 over 4 minus 1 over 2 minus 20. Then we find the common denominator, which is of course 4. 4 into 4 gives us 1. 1 multiplied by 1 is also going to be 1. Then minus 2 into 4, that is 2. Multiplied by -1, which will give us -2. Minus, we have 1. 1 into 4, that gives us 4. 4 multiplied by 20, giving us 80. Okay, so we have 1 minus 2 minus 81, which is giving us -81 over 4. And from here, we can now conclude that our turning point is -1 over 2, -81 over 4. Okay, so we have the turning point, we have the y-intercept, as well as the points which we have on the other side. So because of the space that I have on the board, I'm just going to write the points on the other side, the y-intercept, as well as the turning point. So allow me to rub on top. So from what we have -5, 0 as the points and 4, 0. Then we have our y-intercept to be 0, -20. And finally, we have our turning point, which I'll denote by TP, turning point, which is -1 over 2, -81 over 4. Okay, so we are good to go. So I'm going to wrap this side so that we can now sketch. So from here, that is what we want to sketch, and we have that point, we'll start with a point. So this is negative 5, comma 0. Then we have 4, comma 0. We have our y-intercepts, which will be somewhere here. So this is 0, comma negative 20. And finally, we have negative 1 over 2, comma negative 81 over 4, which is going to be somewhere here. So this will be negative 1 over 2, comma negative 81 over, so sorry, it's not true that this is negative. So our graph is now going to be here. These are positive values. The negative is going to be somewhere here where we have negative 1 over 2, comma negative 81 over 4. So it's cutting somewhere here. But these points, in order for us not to be confused, for the y-intercepts, let me write them this side, which is 0, comma negative 20. Okay, we are good to go. So from here, we're now going to sketch. So our graph will be something that will come like this, then go up, then go like that. And this, we are saying that this is x to the power 2 plus x minus 20. So it's so simple. And we have done it like that. And we are good to go. So since we've done 2 examples and we've seen how to go about this, we'll now indulge our own creativity to see if at all we are able to do this work on our own. So we need to do some exercise. So we'll go to the task. So sketch the graphs following equations. So we'll see how many we can have. So the first one will be 2x to the power 2 minus x minus 3. Then the second one, what should it be? So the second one will be 2x to the power 2 minus 3x plus 4. Okay, let's consider negative. So the second one is 2x to the power 2 minus 3x minus 4. There are only 2. So let us try out these 2 simple questions and see what will happen. So for now, we call it a day. See you next time. And don't forget to answer the questions that are on the board. Have a good day.